If we want to model something by a circle whose center is at y equals 12, and the circle has radius 5, then the picture is going to look something like this. We draw a dotted line for the line y equals 12. We draw a circle of radius 5. We set y this way, t this way. And as we go around the circle, we again think of going around the circle and tracing out the curve. Okay? When we trace this curve out, since the circle is centered at 12 and has a radius of 5, then the highest point we're going to attain is y equals 17. The lowest point is going to be y equals 7. So we're going to be moving between y equals 7 and y equals 17. We can adjust the speed in the circle to make this thing have whatever wavelength or frequency we wish. And of course we could adjust the phase. If we didn't want to start at y equals 12, we wanted to start at y equals 17, we could start at the top of the circle and come down like this. So we have this kind of control. Now this is important because we want to model things. In your text you'll have a lot of problems where you have to model this phenomenon or that phenomenon. And usually the phenomenon is going to be some cyclical thing that varies from some low point to some high point. How does the low point and the high point relate to the radius of the circle? Well, radius of the circle, the diameter of the circle will be the distance from the low to the high point. The radius of the circle, of course, will be half of that. How does the central point for the circle relate to the low and high point? Well, it's halfway between, right? So let's see how that works. In this model, we were asked to determine the model that we'd have to use. Actually, I like the other angle better. We're asked to determine what model we would use for the length of a day. Now on the sheet I think the length of the day went from 9 to 12 hours. Here it goes from 9 to 15 hours. Here it goes from 10 to 14 hours. So we want a model that goes from 10 to 14 hours over a 12-month cycle. In order to do that, what's halfway between y equals 10, which would be represented here, and y equals 14? Well, it would be y equals 12. So we center the circle at the level, at the altitude y equals 12, and we give it a radius of 2, so that it varies from 12 up to 14, back to 12, then down to 10, and up and down like this. What period will we give it? Well, this represents the length of a day over a period of a year. It's going to be 12 months from longest day to longest day. This is the mid-June longest day. This is the December shortest day. Actually, June 21st, December 21st, I believe. If we start at the rightmost point of the circle, our model will go like this, and it'll take 12 months to complete a cycle, another 12 months to complete another cycle, another 12. So we'll have t equals 12, 24, and so forth. What's the omega that goes with this model? Omega is going to be the 2 pi radians around the circle divided by the 12 months it takes to go around the circle. Remember that omega is the number of radians divided by the time. Okay, if we reduce 2 pi over 12, we get pi over 6, so that's pi over 6 radians per month. Coincidentally, we see that the circle, as we saw earlier, can be divided equally into 12 sectors, with each sector having a pi over 6 angle. So each pi over 6 angle represents 1 month of motion around this circle. So here we are in December, shortest day, We come on up to mid-March, equal day and day length, equal length of day and night. June, longest day, back to equal, and down to December again. That makes kind of an interesting model that we can relate to. Right now it's mid-January and the days are starting to get a little bit longer, and most people welcome that. Some people are affected by seasonally, it's called SAD, seasonally affected depression, I think. When the days get short, there's not as much sunlight, people crave light, they get depressed. This is just one model of a variety of very meaningful models that we can make using the circles, using circular models. And we're going to relate that next time to the sine and cosine functions, the standard trigonometric functions.